Thank you. Yeah, he deserves it. No, he's doing a great job, thank you. I asked him not to present to me. My ego is already too big anyway, so. Hello everybody, my name is Roy Osherove. This is a talk about Web3, and I realize that it might be a bit controversial for some of us, many of us, all of us. I think the topic is controversial for all the wrong reasons, and I think that we should talk about it in conferences in a positive context, because it is a technology that is very interesting and has a lot of potential. The uses of the current technology, some of them are not ethical. Some of them are amazing. And I think that's something that we should learn, we should understand. It's like a new type of database. That's what we'll talk about today. Okay, so I'll talk about the why I'm interested in this stuff. We'll discuss the idea of Web3 as a concept, and we'll separate it from the idea of a blockchain. We'll introduce the idea of smart contracts, which is, to me, one of the most exciting aspects of this area. Based on how much time we have, we'll talk about architectures of decentralized applications, the tool stack, but most importantly, we will talk about what skills you would need and what the difference is in developing in this world versus traditional, we'll call it Web 2 world. Okay, so why? I've been a long-time developer. Most of you know me from different contexts, if it's unit tests or pipeline-driven organizations. But it's really, really important for me to continuously learn. And to me, this is one of the most exciting areas that I've come across in the past few years. And I want to share my passion for it. I'm learning this just as much as almost anybody else. I'm definitely not an expert, so all I will share here is my current understanding, my current learning, and also the stuff that I don't know yet as well. And I invite everybody here to learn that stuff and be a noob again. We're all already kind of experienced in a lot of different areas. It's good to be a new person in a new emerging area. I do believe this area has huge potential, not just financial potential, but in terms of allowing new types of applications to exist that could not exist before, or were very hard to build before. So I'm going to ignore all the hype. We're not going to discuss any prices or anything like that. I think that's poison when we're talking about technology. But we are going to talk about this field of unexplored ideas and innovations. The most interesting sentence that I've heard in the context of blockchains and smart contracts is that I would want to build an application on them when I choose to remove control. That is, I'll build something when I do not want to control it. And that is almost the opposite of what we're building in everyday life, in every other application. And once we keep this sentence in mind throughout this conversation, I want you to see how that can be manifested. Now, is it manifested today in all types of blockchains and cryptos? No, because human nature is also involved. So I want us to think about this area like the early days of the Wild West in the US, and they were just setting up the train lines, and there were, Indians everywhere, and everything was dangerous, and everything was crazy, and everyone was kind of reinventing and looking of what they can do in this new area. That's what it feels like to me. And I think that's the best time to get into these types of fields, because it is a wide open for innovation. Nobody really knows what they can build on it. There are a lot of different trials, a lot of different errors, like a lot of different errors. Okay, so what is Web3? I looked for interesting discussions on it, and I came across this one, which is from the Ethereum homepage, and I kind of connect to it. Web 1, as we kind of used to know it, was initially how the web got started. And at the beginning, it was mostly read-only. There were only a handful of pages and that basically companies controlled, but they were mostly governmental agencies and stuff like that. So it was kind of read-only. You couldn't really create new content on Web 1. In Web 2, which is where we live today, which is the read-write web, there was an explosion of creativity. And those of you who lived in the beginning of this era If you remember, not MySpace, but if you remember GeoCities, does anybody remember GeoCities? Wow, that was an amazing explosion of creativity. You could create blinking text all over the place. You can do whatever you want in that old era, but slowly over time, companies have basically taken over the content. So today, as users of this internet, we are able to create content, but we do not own it. Basically, huge corporations own that content. Basically, there's this centralization that's happened. It's very, very hard to get rid of. I think we're all aware of that. And it's not just a privacy issue, it is monetization issue as well. A lot of people are basically are not able to either make money from the content that they make, or they have to share that profit with a lot of middlemen in the middle. By the way, the music industry is a perfect example of this, and something that can be absolutely disrupted. And the reason I'm talking about that is because one of the things that I'm building as part of this kind of innovation sprint that I'm having is I'm trying to create my own product as a side hustle. I'm a musician. I wanted to see, can I create something in the music world that would help to decentralize some of that stuff? So that's why I'm really interested in these topics. And if we have time, we'll talk about that as well. Web3 is the read, write, and own web. That's at least how it's described. That's, I think, where the vision is. And the idea is that instead of just creating, we are able to own or prove that we own. And we are able to show, and we are able to have provenance over the things that we control, which means at the basic level, we can be our own banks, right? If we can have our own currency. So Bitcoin was the first example of you own the thing, nobody else owns it, for good and for bad. But we can also own a lot of other different things. That's where the smart contract stuff happens, and we'll talk about that. So there are four main pillars for Web3 core concepts, if you will. It is decentralized, so instead of large centralized entities, ownership is distributed by people. It's basically whoever wants to can take part in this chain because it's permissionless, or at least the blockchain that we choose to use can be permissionless, and that's where we are aiming. So there are multiple different types of blockchains, there are multiple different types of protocols, but when we're talking about these values, in my head I'm thinking about stuff like Ethereum, or Bitcoin even. But specifically when we're talking about logic, extra logic on top of the blockchain, I'm thinking about stuff like Ethereum and things like it. Permissionless means that everyone has equal access, right? If, for example, you wanted to get a decentralized loan of something, you don't have to get permission from a bank to get that loan, but you can actually approach a smart contract, and as long as you have a wallet or an account on the blockchain, you are able to take a piece. Nobody can tell you not to do it, as long as you live up to the rules that the smart contract decides. Native payments, instead of having to rely on government money, we have cryptocurrency, which is basically a disruption of monetary currencies or fiat currencies. What's interesting here is that the native payments are connected to the blockchain, which means that when you do operations, you're able to charge or pay or move things as part of the transaction on the blockchain. That is fairly unique. Imagine having logic that also has financials built into it. It sounds really weird. And to me, weird is good because that's interesting. What can you build when you have these types of things? And lastly, trustless. Trustless basically means that instead of having centralized actors in the middle between us and what we want to do, the code, the smart contracts that exist on top of the blockchain, which we can see their code, we can verify their code, and we know that they are immutable and not changeable, which means that we trust those smart contracts to do whatever logic that we want them to do. So instead of having a person in the middle that we have to trust, we can basically remove trust between me and a third party and have a smart contract between us that allows different interactions or collaborations. And this is all very, very high level. And at the beginning, I've been involved in the world of crypto probably since 2012. And I got introduced to Ethereum around 2015. And at the beginning, I really thought that Solidity and the language that it uses is really kind of like a toy language. I looked at it and like, okay, fine. You'll see what it looks like. Kind of a very basic JavaScript. It looked like a toy language. It took me a few good years to really have like a penny drop and realize what we can do with that stuff. So those things, they're not just words today for me. Today, I can actually see that there is an option that these things could actually be true, at least in some context for some decentralized applications. And that is a very, very kind of a scary future, because if you can build something that truly looks like this, that you could never build before because we are relying on these huge actors in the middle, that kind of opens up a whole door, a whole like can of worms. What can we build? And today, people are using that stuff to build the most basic, rudimentary, annoying, frustrating things because they're just learning how to use that technology. So of course, if you've heard of NFTs and all that stuff, they're based on smart contracts. But they're like the most basic, rudimentary smart contracts. They're like the hello world of smart contracts, if you will. So if a hello world of smart contracts can create such a huge buzz and difference for a lot of different people, just in the sense that they can own something, and we can argue what owning means in this case. But just imagine the fact that this, literally like scratching the surface on top of that stuff, created this something that creates a lot of passion around the world. What can you do when you actually dive deeper, and you actually use the logic, you actually dive deeper into what the smart contract can actually do? That's why I'm really interested in that stuff. I don't care about NFTs. I don't care about that stuff. I care about what happens in the next 5 years. What can we actually build with it when the hype dies down? And I really hope that we get a bear market so we can build and nobody talks about the price anymore. Just build it. Okay, so examples of use cases. Of course, currency is the first use case. We've all heard about it. But ownership or partial ownership of something is the second use case that we're starting to explore. For example, instead of just owning NFTs, you can own a domain. So there is this decentralized domain service called ENS Domains. It's actually very successful, and it's trying to connect .eth domains into the real world. So imagine owning a domain without having to go through a centralized domain ownership like ICANN, etc. I don't know if you've ever owned a domain, but domains are a really good way to have something that everyone can see. You have provable ownership, and it's managed by a smart contract. It's really quite beautiful. Loans and basically decentralized finance. Imagine recreating some of that world in the world of smart contracts. Today that exists. So loans and other things like that today exist and they work. Like to me, when the penny dropped is the first time I saw an automated loan smart contract that allows you to put collateral and then receive a loan based on that collateral. You get liquidated automatically if price goes to a different location that you wanted. But you do not need permission to get a loan. You do not need a bank to get a loan. That, to me, whether it's very early, etc., I don't care. What I care about is the potential of what that can do. It was an amazing feeling, and I highly recommend everybody to try to dip your toes and to become a user of some of these services. I'm not talking about pyramid schemes and all that stuff. That's probably 80% of the services out there, is people trying to take advantage of the fact that we are in this Wild West. But the core technology is sound. The core technology is interesting. Escrow contracts. Imagine a contract that knows when something has happened and automatically sends something or allows an action to happen instead of a person, such as purchasing something. Royalty payments, that's the field that I'm really looking into. As a musician, something got played, I want to get paid. Right? Today, that could be a huge disruption, and there are at least 5 or 6 different services running, trying to create that world today in smart contracts. Right? And that area starts with something called music NFTs instead of just images, but later royalties based on those and playing them and create an example of a decentralized Spotify that as you play, you get paid. because your song, you can prove that that's your song. You can prove that the royalties are deliverable to you, etc. It's pretty amazing, but I really have no idea what we can build with this. Everyone is looking. That's why there's huge innovation, but it's very hard to see it if you don't dive in. So I believe, and I think everyone would agree, that we haven't found the killer applications yet, because this is very much like the early days of the internet, is that you would get a lot of doubt. Well, okay, I don't need to go and listen to a streaming something on a website. I can listen to the radio. There are a lot of different options, but there is a difference between what we have today and what we potentially could have tomorrow. So that was kind of the vision of Web3, but Web3 depends on the ideas of blockchains. And blockchains allow us, or are supposed to be the security layer, or the proof layer, the consensus layer of the things that we are supposed to do. So when we are proving that we own something, that proof happens as a transaction on a blockchain, which is very, very hard to fake, and basically allows us to use that as a database, if you will, which is a very slow and very expensive database, but for specific uses can be amazing, specifically for cases where you do not want to trust anyone else. You just want to prove that you own something without somebody else having to vouch for you, or prove that you did something without anyone else having to vouch for you that you did it. So we have distributed trust and decentralized because usually blockchains run on multiple nodes. We have security because you have multiple nodes, and we have two types of main consensus algorithms, proof of work and proof of stake. We'll talk about that in a couple of minutes. And independently verifiable. Now, I put the word here potentially, because not all blockchains implement those things, which is, again, adding to all of that doubt. So some blockchains are more secure than others. Some blockchains are more decentralized than others. Some blockchains are completely private and they're implemented by a bank somewhere, which means that they're not decentralized. They are centralized blockchains. So what makes them decentralized is that the consensus is spread among thousands of different machines around the world that are trying to validate or to mine the next transaction. So Bitcoin and Ethereum have proven to be these types, and there are others that are slowly growing to maybe try and take their place. There is a lot of competition in the area. Some blockchains are more decentralized than others. Some are much faster than others. And there's a lot of balance between decentralization, cost, speed, et cetera, et cetera, et cetera. So it's a very nascent, it's a very early stage of development. We don't know which one is going to win yet, or maybe there's going to be a few. Right now, Bitcoin and Ethereum are the most interesting, but for a smart contract world, Ethereum kind of led the world in the idea of smart contracts. I'm not going to touch on this too much because that's not the focus of this talk. But a blockchain is a chain of blocks. And those blocks basically list a bunch of transactions, and those transactions cryptographically are provable to have been in a specific order, and each block is cryptographically related to the previous block. Which means that when you run, or when you look at the blockchain, you see the entire history of that blockchain, all of the transactions from the first block ever. And that is very important because this is where the security or the provability comes in, the verifiability. So we are going to assume for this talk is that the blockchain is one that we can trust. And if you want to, you can dive into this area and understand how it works, that we can spend a whole day just on that stuff. I want to address a big elephant in the room. When we talk about blockchains, one of the biggest things that people are hearing and they believe is that proof of work is harmful to the environment. Because a lot of blockchains, they use a lot of CPU and a lot of power to actually create those transactions and validations. That's true. They are power consuming. But today, we don't just have proof of work. So if you're worried about contributing to destroying the environment, etc., and I'm going to set aside how true this is and how there are actually mitigations for it, but let's assume this is absolutely true, because I want to get this out of the way. We have a different type of consensus mechanism that a lot of different blockchains are moving to. and it's called proof of stake. And proof of stake does not require that amount of power. It does not require mathematically computing things that require a lot of different energy, basically. So the things on the right, especially Ethereum, which is currently moving to that world of proof of stake, are in that world. Bitcoin and the original Ethereum are in that proof of work world. So when we are looking into this technology, we should assume that we're going to work on a blockchain which is somewhere on the right. Okay, to get basically so we don't feel like we're actually destroying the environment, etc. That's where we are going. So in my head, even though I'm working on Ethereum today, we're expecting in the next few months a move to the next version of Ethereum, which is basically a move to proof of stake and a lot of other different things. It used to be called Ethereum 2.0. These days it's just called the merge, okay? They're literally merging code into the branches and actually then deploying, and the nodes across the world will then implement the new version. Proof of stake just basically runs on validators instead of miners. Miners require computation power. Validators require stake. Basically, that you have to stake a simple amount of cryptocurrency to be able to become a validator. You lose it if you become untrustworthy. So there is a financial incentive. So the consensus algorithm is very interesting, and I highly recommend that you look into it. So we are in the world on the right. Specifically, if we're looking at Ethereum versus Bitcoin, and this is why Ethereum is much more interesting to me, Bitcoin was and is an amazing technology. Ethereum takes everything in Bitcoin in that world and adds on top of it a layer of logic. So here, if on the left, we can send something from Janine to Bob, on the right, we can send it, but add logic on the send. If some specific thing has happened, if something is true or not true, et cetera, et cetera, et cetera. There are no smart contracts today on Bitcoin. Bitcoin is specifically designed to do one thing really, really well, and it has proven that it can do it very, very nicely. Ethereum is slowly proving itself as well in that world. And every year and every day that passes, it's proving itself more and more. The amount of different smart contracts that are built on Ethereum is staggering. Of course, the amount of errors and the amount of mistakes is staggering as well. Smart contracts are just computerized transaction protocols. Imagine a function, but it runs on the blockchain. And what that function does, it can change storage, can change variables on the blockchain, but those variables are there, and everyone can see them. And you can write almost any type of logic you want because it is Turing complete. This is what we call an EVM, or Ethereum Virtual Machine. And today, when you write smart contracts in EVM-compatible languages, there are multiple EVM-compatible chains out there. So technically, you can take the smart contract that you wrote and you can try to translate it and actually work in different blockchains. You're not tied to a specific one, but some of them require different types of development. But smart contracts as a concept is that you can add logic into the blockchain and actually perform very interesting actions on top of it. So that's our focus. I try to look for an interesting analogy, but imagine that you have this huge Excel file and the whole world can see the same Excel file. Everyone can see it. But Excel file, you can see the list of transactions. You can have tabs with columns, so imagine each tab to be a smart contract. So you have different fields for each smart contract. And in each smart contract, you can have formulas, which is logic on how to do something. But let's add on top of it the fact that you can only add rows. You can never remove a row. Once you wrote a row, it is immutable. You cannot change it. You can only change the state later, but you can always recreate the entire state by running through the list of rows. You create a formula, it is read-only. You cannot change it later. There are ways around this for now, but by default, when you deploy code in most blockchains today, smart contracts, that code is read-only. You write once, you deploy once. And from that moment on, if you wanted to change it, you actually have to deploy a new version of that, but the old version will continue to exist. That's interesting. That's already kind of a big change. Anyone can create new smart contracts. Anyone can create new formulas or logic. But also, any row and any formula can also handle money. So imagine that as you're adding a row, you can actually request that adding a row actually costs something to the person who's adding it. Okay, so write operations actually cost something because it's part of the security protocol. So otherwise, you're going to spam the blockchain. But you can also create custom logic that requires payment for the owner of the smart contract. Or you can move payments between different people, different accounts. You can manipulate money, and it costs money to change data on the Excel file. That's kind of a very basic, terrible explanation of that. Here is a hello world in a way for a smart contract. It kind of looks like a class, right? If you replace the word contract here with a class, this is a language called Solidity. That's the language that I started in. There are also other languages like Viper, etc. They get usually, in the world of Ethereum, they get compiled to the same bytecode and actually get deployed onto the blockchain and executed. So this contract, which is a counter, has a uint public variable. And when you declare variables like this, you're basically declaring that you're saving storage on the blockchain. Right? In our world, this would just be a class with a variable. On the blockchain world, that count is now part of that immutable history. So if you want to change count, like in these functions like increment and decrement, calling these functions requires a transaction. So it's provable that you've actually incremented. It's provable that you've decremented, which means that these required transactions, it actually cost you money to call them, which is called gas on the Ethereum network. That looks like a completely contrived, why would you want to write a smart contract like this, right? But just so you understand how simple it is to create the most basic type of information. What if we take the same idea and we say, okay, actually this is a special counter, and this is my smart contract, and let's say that I've created this counter that allows you to compete with others on who got to the number 100 first, okay? So to pay, so you have to actually pay me to do the increments, just as a simple game. And here I have this special require call. The require basically will revert if the argument is false. So I can look at the message.value and actually see whether whoever is calling the transaction is actually paying. So if this is true, I will change count and 0.1 Ether will transfer to the address of the smart contract. The smart contract can actually save money inside it. I can withdraw it. It has its own balance. Okay, that's interesting. It's kind of weird. But what can we do with those kind of things? Well, what if we implemented a simple voting system instead? What if we had two candidates, vote A and vote B, and we allowed people to vote on those candidates, but we wanted the vote to be verifiable. We wanted a person or an account to only be able to vote once. Okay, so I can add another require. Require that that person, which is message sender, only voted once. How do I do that? You see that mapping there at the top? The mapping is basically, imagine a dictionary, okay? And the dictionary is between addresses and booleans in this case. Imagine an unlimited space for that dictionary. So that space lives on the blockchain as well. I could technically, whenever someone tries to vote, I can make sure that they didn't vote, and then in line 10, I'm setting their vote status to true, and that's it. You notice that there is nothing here that removes the status of the vote, which means technically for this smart contract, you can only vote once. Now, if I can look at this smart contract and I can look at the code, then I can trust it. I don't need a third party to tally the votes and tell me who won. Make sense so far? So voting is actually a transaction, and I can add pieces of logic into the voting. Let's take this one extra space, one extra thought later on. So imagine you have candidate, and the candidate is an address. It is another account on the Ethereum blockchain. And I have a constructor, and I'm initializing this new instance of a smart contract, which I'm deploying, that it's going to be a vote between these two types of addresses, these two addresses. And I'm allowing people to vote, and it's payable. So technically, I can even demand money for voting. In this case, I'm not demanding anything. But people can actually send money if they wanted to, because let's say that they're voting for some kind of a cause. And at the end of the voting session, we can have a pay winner function. And the pay winner function requires at least 100 votes. Okay? In this case, actually, it's 101. There's a bug here. But it needs 100 votes. Otherwise, you will not actually be able to pay the winner. You have to wait. Notice there's no person in here. The code defines everything. This all runs as transactions on the blockchain. Now, and then, once pay winner has is called, then whatever balance the contract has will be sent either to candidate A or candidate B. Okay? I'm just kind of walking through some of these weird things that you can do. Is it useful? It kind of maybe could be useful in some interesting context. So imagine a smart contract which is for charity, and everyone gets to vote on which charity gets the money, as an example. Right? Hopefully you're starting to see what we can do on it, because remember, this is not running in memory. This is running on a blockchain. It's verifiable. You can see all the transactions. You can see all the votes. And once it happens, you cannot change it. There is no way to change a contract once it's deployed unless you specifically write code that allows you to replace the logic. By default, contracts are immutable, which means that whenever I call the smart contract, I know exactly what's going to happen if I look at the code. And by default, most smart contracts publish their code because they want to be trusted. So imagine a government agency that has an application, but you can see all of the code for that application. But it's not a government agency. It is a decentralized agency. That's a very powerful thought process that we can go to. So I wanted to jump into the differences before we jump into architecture, because when you start to develop in that type of world, there are a lot of things that become really weird really fast, okay? First of all, I highly recommend that everyone here tries to write a few smart contracts and actually tries to deploy them into one of the blockchains. And there are multiple types of blockchains. There's layer 1, layer 2. We don't have enough time to cover the whole thing. But the most weird thing that you'll start to realize is you cannot change the code after deployment. Do you know how scary that is? Most developers don't even test their code. Are you going to deploy code that has financial features and actually deploy it without testing it? Well, you're definitely going to do much more testing. Trust me. Even if you're creating a simple NFT smart contract. By the way, what's an NFT smart contract? It's literally a mapping of addresses to IDs, a running counter. And each ID is mapped to a specific URL, which is a string for a file that's hosted in IPFS, which is a decentralized storage system. But that's basically like, if you try to think what an NFT is, it is a proof that you created a transaction, that you have an ID, that ID is linked to your account, and that ID has a URL. That's kind of the entire thing. It's like a connection. It's a glue point. It's the most simplified smart contract you can ever think of. Then there's a bunch of security on top of it to make sure that people are not cheating, people are not able to pay for something and get nothing in return, et cetera, et cetera. All these things are added security that we have to write, because there's a lot of people that are bad actors. They're trying to look at the code for a smart contract and look for vulnerabilities. And there are a lot of vulnerabilities because developers by default do not think about security. I did not think about security as much as I would have liked, which is mostly I didn't, until I started writing smart contracts. Suddenly, everything changed. Oh, I can only deploy this once? It's really, really scary. Suddenly, I started thinking about all of these different use cases, etc. If you want to get better at security today without blockchains, give yourself this mental model. What if the code that I'm writing is read-only? What if I can never change it after deploy? It will change the way that you think about your code. You're going to start looking at all these places where someone can go and interfere. Because if people can actually steal money from your smart contract, they have a lot of incentive to do it. Second, storage is costly, which means you start thinking about storage optimization. Maybe you want to actually minimize the amount of storage optimization that you have. We start thinking about fat protocols and thin applications. In the world of the Web3 and smart contracts, most of the value of the application that we're writing is actually in the smart contract. That's where most of the value is today, which means that the applications on top of it are almost conduits. They're very, very simple conduits on top of it. And that means that we have to start thinking about protocols at the bottom, which are the smart contracts, and applications at the top. That's a very different way from thinking in the world of Web 2. It's all visible. Every action, every transaction, everyone can see it. That's good and bad. So if you put identifiable information in your transactions, you're basically creating a bad time for your users. But it's good if you're creating something that other people can use. Imagine that the web is like a bunch of Lego pieces, and my smart contract can interact with your smart contract. I can read any address on the blockchain and see whether you own a specific token, and so I'm allowing in my smart contract for you to vote if you have a specific NFT or a specific token. Or I'll allow you to vote on my smart contract if you have, in your transaction history, have shown that you have donated to a specific other smart contract, etc. So there's this built-in interoperability, which is very, very powerful. What can we build with it? And today, it's called money Legos in the world of decentralized finance, but it doesn't have to be financial. Your wallet is an identity in that world. You don't need to sign in with a user and a password, because technically you can prove that you own a specific address with a simple signing operation, which is not a transaction, just a simple local signing, cryptographically. So different types of sign-in can be possible, and you'll see a lot of decentralized applications that do not require you to create a username and an email and a password. They just require you to sign a simple message to prove that you own the specific address. That's it. It's a very powerful way to do something. Centralization versus trust. If I can technically create patterns in my smart contract that allow me to replace the logic. When would I do that? If I'm afraid that I'm going to make a huge mistake, or if there's a lot on the line. So I can create like these proxy patterns, etc., where I can replace logic, because I can have a URL of another smart contract, which I call, imagine like a forwarding pattern. What do I do as soon as I do that? I reduce the trust of the users in my smart contract. Because if I'm trusting your smart contract, I can see the code, that's one thing. But if I know that you can change the code tomorrow, then maybe you have an incentive to change it tomorrow for your benefit instead of my benefit. So by allowing upgradability in smart contracts, we are actually reducing trust because you can change the code. The whole point was that you cannot change. So you will see that some services, they specifically claim we do not have upgradable contracts. And some services have upgradable contracts because they're still learning, but at some point they will lock the contract, again, through code. It's just functions and a bunch of storage. And it is the slowest database in the world. So only use it for things that actually make sense. When you build something on it, remember the key differentiation. I want to build something on it because I want to not have control. That's when you want to build something. Not if you're just trying to recreate something that already exists, but if you're trying to disrupt something, where you have a bunch of middle actors in the middle that usually have control, and you want to reduce that control. Okay. Finally, just a couple of minutes. Skills. If you want to jump into that world, the easiest to jump in would be people that have front-end experience today. Okay? Because almost the entirety of the front end of the world of Web3 that talks to smart contracts is usually just built in regular JavaScript frameworks. So React, Svelte, Vue, Next.js, whatever. You learn, if you already know that stuff, you're halfway there to communicate with a smart contract. Then you learn how to use an extension such as Metamask, etc. And those APIs, they abstract away a call to the nodes that hold the smart contracts. Calling a smart contract is just an RPC call. Basically, it's an API call, but the API is on a node which is part of a decentralized network. So as long as we understand that, everything else is transactions and signing something locally inside the browser, which is through usually Metamask, and Ethers is a library. If you want to learn backend, then learning Solidity or Viper is basically where I would recommend. But there are a lot of different skills even here. For example, gas optimization. Remember, every action in smart contracts actually costs gas. So if you have really complicated functions, the user who's actually activating the transaction will have to pay more, okay? So it's not unlimited, you actually have to pay for complicated logic. So gas optimization, security and auditing. If you're into security, this is a very powerful way to jump into it. Upgradability or design patterns in the world of smart contracts. Standards, oracles, how do you bring information back from the outside world into smart contracts? And testing, of course. Optimization and networking at the lower level. If you want to work on really low level and you're coming in from, let's say, embedded or high-performance computing, etc., working at the node level is a very powerful way to get started. And finally, there are logical things that we can learn. How do DAOs work in financial incentives? How do you build a product that has incentives built in that actually create value for the users? But it's not a pyramid scheme, but basically something that can actually exist as a network without requiring an outside entity. And today, a lot of it, there's a lot of knowledge being gathered. How do you create tokenomics, basically? This tokenomics or token economics is a huge, interesting field. Okay, and to me, it's you don't have to be a technical person to really be good at this stuff. Okay, so I have this kind of this thing. I'm going to share this with everybody. If you want to learn more, you can. I highly recommend. If you want to write your own first smart contract, go to cryptozombies.io. Write a simple smart contract there. There's a really good guy, like a French guy at eattheblocks.com. He has a really good YouTube channel. I've learned a lot from him. But there is a vast world of information at ethereum.org to start learning, and I highly recommend it. Thank you very much, everybody. May the force be with you.